Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science N3. So in this platform we shall be focusing actually on friction as a continuation from question papers and revisions, the part that we're working on. So in this case we want to see what we are having here from the question that we are given. Actually, if we are to cross check here, we are given a question which is in question number 4, and they've got a 10 marks in total. There is a total of 10 marks there. So if you're new guys, you can consider subscribing so that you won't miss any of these classes like this that we shall be working on revisions for engineering science N3. So looking at the first question that we are given on 4.1, we are given to explain the difference between static friction and kinetic friction. This type of a question, actually we worked with this type of a question many times. Anyways, these are the ways that we are supposed to answer this type of a question. Okay, we have got the static friction, which opposes the initial movement. That is, the force required to move the object is called static friction. Where am I getting the pressure there? This is friction, guys. You see this thing of working with many topics at once. Okay, this is static friction. And the kinetic friction opposes the force causing the movement after the body is in motion. And the force required to keep the object in motion is called the kinetic friction. So actually kinetic friction, there has to be movement. That is, when you're talking of kinetic, now movement, it is movement. Static is just on its initial position. That is initial position. Okay, so when it is an initial position, the friction that is going to act is the one that we are calling static. All right, then kinetic, there is already movement, so it's just to keep it moving, something like that. So, and then we are given on 4.2, a minibus weighs 1,600 kgs, rests on a plane as shown in Fig 4 below. Calculate the smallest force needed to pull the mass up the incline of 25 degrees if the coefficient of friction is 0.36. All right, this is what we are given here, guys, on 4.2. If I have to cross-check properly, we are given the coefficient of friction, which is 0.36. All right, maybe if to have this down so that maybe I can do some adjustments here. Let's just put it this way. This is what we are having, 25 degrees here, and this is the object, which is the minibus in this case, and there's a force that is acting this way, the one that we do not know, but we know that there's an angle of 20 degrees here, so the angle is here, this one. All right, and this is 1,600 guys. Okay, 1,600 here. So we've got a mass of 1,600 kgs. All right, this is what we have. And remember, guys, I talked about a condition where you are supposed to find the components here, because we know that actually the coefficient of friction is equal to the frictional force over the normal reaction, which is actually the weight, just like, but this is the resultant actually that you're with the resultants that we are talking about. All right, so if we put it like the normal reaction, it can actually make sense. And we have components here according to this 20 degrees. As you can see, this is opposite, and anything that uses opposite has to do with sign, and anything that uses adjacent has to use cos. So this is going to be F sine, because it's on the opposite, so it's F sine 20 degrees. All right, this is going upwards like this, and this is going this direction like this. All right, so this is going to be F cos 20 degrees. All right, so remember the build-up of a force diagram, guys, of a triangle. This one is supposed to be like this. All right, so this going this way and this going up. All right, which is the same thing that is going to happen if we are to put a triangle here. It's going to look like this, where you're going to have our 90 degrees here, and this angle of 25 degrees will appear here as 25 degrees. All right, so this time, according to this 25 degrees, we are seeing that this is now in opposite. According to 25, this is your opposite, and we said anything that uses opposite is sine. So this one is going to be affected not by this force, but by the force which is the weight component of 1600, and we know that the weight component is equivalent to mg. All right, so let's just write this as the weight component sine theta. So it's going to be sine theta because it's in the opposite. Actually, let's put the angle which is sine 25 degrees. All right, let's see about this side here. This side, which is the adjacent. As you can see, the angle and the right angle are on this side, so they are adjacent to each other, so which means you're going to use cos. So this is going to be w cos 25 degrees like this. All right, and this is going this direction, and this is going this direction like this. So this is what is important. The one that at 90 degrees they will be pointing, this one will be to the 90 degrees, okay, and this one will be from the 90 degrees. That is how you, just like this one, this is our 90 degrees here, so this is going to the 90 degrees, and this one is from the 90 degrees. All right, and don't forget that we'll be having the frictional component in the other direction. So this will be the frictional component, which is the frictional force, because we are pulling, we are going upward there, so definitely frictional force will be going the other way. That is how you work out. This is going up. Remember, you are going up and another force is taking down this way. So this is where you're going to have your frictional force. All right, now I told you guys that this is the formula. This is the formula that you're supposed to use in order for you to find F, because you're going to form an equation. Remember, whenever you have an equation, you can solve for the unknown. So in this case, our unknown is F. All right, so let's formulate the equation. How are we going to formulate the equation? We are going to find the frictional force. So the frictional force that will be added together with this, because as you can see, the frictional force is going this way and the weight component is also going this way. How you see, guys, what is happening here? These two, they are going the same direction. So that means if we add these two, they must give us this one, which is going to the, which is going upwards. This one, which is going up. These are parallel components that we are having, but the parallel part here is the sine, but here it's a cos because of where the angle is, but still they are parallel components. All right, so that means these two are going this direction and that one is going the other way. So if we add these two, they must give us this one. Okay, so that is how you can formulate, or you can use the concept that I did last time. I just gave you a formula direct, that it's this one which is going up, F cos 20 degrees, minus this one which is going this direction, which is W sine 25 degrees. Okay, or you can just formulate an equation. How do you formulate an equation? The frictional force plus this force, because they're all going the same direction, with the W sine 25. So it's going to be plus W sine 25 degrees is equal to the one that is going upwards, which is this one of F cos 20 degrees. Okay, as we can see, guys, these are the ones which are opposing each other. These two, they oppose each other this way in the vertical. In this way, that is going up, another one is going down. These two, so we don't count them because these ones, they are parallel like this, and these are perpendicular. All right, so we don't talk about this for now. We are referring to these three, 1, 2, and 3. All right, so let's make this the subject. Is going to be F cos 20 degrees minus W sine 25 degrees. Why keeping this W? While least we say it is equivalent to mg. So you can substitute this, which is going to be F cos 20 degrees minus this W here, which is mg. So this is the mass, and we know that the gravitational acceleration is 9,8 meters per square second, like that. All right, so this is what you're going to substitute. So that's going to be 1600 by 9,8 like this by sine 25 degrees. So this is one thing now. All right, so I want you to do a favor for me, guys. I want you to use your calculator to find the value of cos 20. All right, if you do that, you're going to obtain a decimal like 0.93967 something. So 3 decimal places, this is going to change. This is going to be 1, which is going to add, which is going to give us a 4. So it's going to be 0.94. So that's 0.94f minus, I want you to multiply these 3 together, combine these on your calculator. You are going to obtain something like 6626,654. Okay, because there is a 3 which is following here, and this 3 cannot change this, so it's going to remain like this. So this is our frictional force. All right, we don't know what you're going to have, but as an expression, this is what you're going to have. So you just leave it like that. All right, just leave it like that, because you need to use it later on here to form an equation. So we have to find the normal reaction, which is something like this. So this is our normal reaction, just like what can I say, it's going up. So it's going to be together with this here. It's going to be together with this here. They'll be in the same way, these two. All right, so if these two are in the same way, which means they're going to add, and they'll be equal to this one, which is going down, this one, the perpendicular. As you can see, these ones are going up and this one is going down. So you can just form an equation, or you can add the two like this. The normal reaction, which is the reason why I'm not using this W like this, because we used like a part where we use this small letter W, but this one is the big one. So let's just use NR so that we don't confuse each other. Okay, let's just use this one so that we don't confuse each other. So if we add it to this one, there's no equal there, we are adding. If we add it to this one, F sine 20 degrees like this, it must give us this one, which is going downwards, which is still in the perpendicular way, this one, which means at 90 degrees, this one, but it's going down. So we are going to equate to W sine 25 degrees like this. But we know this W is not this one, is not this one for normal. This one is the one for mg that you're going to take. So this one, just leave it like that. This is the one that you're going to calculate here. So you could have just straight to the point made this the subject. So anyways, let's just make our normal reaction the subject. So it's going to be W sine 25 degrees minus F cos 20 degrees like this. So that's what you're going to have, and this is mg. So you can substitute our mass and our gravitational acceleration. That's 1600 by 9,8 by sine 25 degrees minus F cos 20 degrees like that. So you just put your values in a proper way, guys. This is what you're going to obtain at the end. If you combine all these values, they are going to give us 14210,906. There is a 1 there, so this 1 cannot change. This 6 is going to remain like that, minus cos 20, which is this cos 20, guys? This one that we are subtracting is F sine, so F sine 20 there. So this is F sine. Yeah, I wrote it way. I don't know how I ended up with a cos here. This is a sine there. So this is F sine there. Okay, so sine 20, that will be 0.3202. Yeah, so round off to 3 decimal places is going to give us 0.342 f. All right, because there was 0.02 there, so this 0 cannot change these 2, so it's going to remain like that. So this is the normal reaction, guys. All right, now it makes sense. Now it makes a lot of sense, because we are just going to substitute into the formula now to find f, because we know that this is equivalent to the frictional force over the normal reaction, which is the coefficient of friction. We are given as 0.36. Remember, we talked about the coefficient of friction here, which was actually 0.36. So what am I going to do? I have to take this value that we are given, then substitute this into the formula. That's 0.36 there, like this. 0.36 is equal to this. Where is our value? This is our value here. So you're just going to substitute this as it is. Okay, don't freak out, guys. That is how this question is most of the time. 0.94 minus 6626,6. There's f here. All right, 54, like this. So you're substituting this value over the normal reaction, which is this expression here, so which is over 14210,906 minus 0.342 f, like this. All right, now it's a normal equation, so someone can just cross multiply here. So make sure you cross multiply. This is going to multiply this, which is going to give us, if you multiply properly, guys, this is what you're going to obtain. That's 5115. Yes, that's 5115,926, because that one cannot change this 6. It's going to be 6, like this, minus this value again multiplies this. You multiply everything, that is to cross multiply. So this is going to be 0.123. Yeah, this is going to be 123f, which is equal to 1 is going to do the same, but as you can see, multiplying by 1 does not change anything. So this is going to remain as it is, like this. This one will remain as it is, guys. All right, this is what you're going to have at the end. Now what am I going to do? I'm just going to make f the subject to solve for f. So using our mathematical skills, guys, avoid working with negative values, so I can transpose this to this side so that it will be a plus. So I'm going to add this value and this value together, which is going to give me 11742,58. So you add this value and this value because it crossed equal sign, so you to add. Then you transpose this here to this other side where there is f here. So as you can see, it was a minus. The moment you transpose it, it will be a plus. So it's going to be 0.94f plus 0.123. So you add these two now. So it's going to be 1.063f, like this. All right. Now from this information, guys, you want to calculate f, so definitely we have to divide by this value here, divide by that value there. So that's going to cancel. So therefore our f is going to be, if you divide these two values, it's going to give us something like 11046,64158, something like that. So just round off, which is going to give us 11046, that will be 123, which is 642. 642, yes, because this 5 is going to change this one into a 2, like that, and that is in newtons. Okay, so someone can convert to kilonewtons, which will be, to kilonewtons, it will be here 1, 2, 3, so it will be 3 digits after the comma, like this. So it's going to be 11,04, but to 3 decimal places, this 6 now is going to round off this 6 into 7. That will be kilonewtons. kilonewton like this, since we need 3 digits after the comma. But you can just leave it like this, it's still one and the same thing, or you can write it in kilonewtons. Still again, it's one and the same thing, because we are not given the degree of accuracy to say leave your answer to 3 decimal places or to 2 decimal places. We are not given, but following the instruction that you'll be given at the beginning of the question paper, that the degree of accuracy should be 3 decimal places unless stated otherwise. So that's, guys, how they ask these questions. So we shall meet again in another class working on engineering science N3, past papers and revisions from Meson African motifs. Don't forget, guys, to share our classes to your friends and colleagues so that they also can have a benefit from the information that we are having from Meson African motifs. Till we meet again.